Professor Jeanne VanBriesen is the Duquesne Light Company Professor of Civil and Environmental Engineering. Excuse me. She received bachelor's, master's, and PhD degrees from Northwestern University before joining our faculty. Professor VanBriesen.
I want to talk to you today about your resources, your water resources, mainly in your rivers, your energy resources, and what may be your regret. Let me tell you first about water resources. If you haven't heard me talk before, you know that I am passionate about water resources. Water is so incredibly important, perhaps the most important resource that any society or group or country can have. Without water, there is no life. Most of the water on our planet won't help with that life thing. Most of it is salty and inaccessible. Fresh water on the planet is largely stored in glaciers and in groundwater, also inaccessible. A very small fraction of the fresh water on the planet is available in your rivers. 0.5% of the stuff not stuck other places is in your rivers. That tiny little bit, 5 out of 1,000 gallons of water, is what you have built your entire civilization on. Your cities are all built on your rivers. The ones that aren't shouldn't have been. So here's Pittsburgh. The Allegheny River and the Monongahela River come together to form the Ohio River, and we have our famous three rivers meeting at the point. But of course, we are not the only city built on water. Here's our nemesis, Philadelphia, built with two rivers. We have both the Schuylkill River in the middle and the Delaware River on the far eastern side of Philadelphia. The Delaware River divides Philadelphia and Pennsylvania from New Jersey. You may have heard people say that there's a possibility in the future that we're going to fight wars over water. I have to tell you that we have been fighting about water since we arrived. The origin of the word river and the origin of the word rival are the same. Those people over there on the other side of the river, they are your natural rivals. No offense, New Jersey. Your natural rivals for this incredibly important resource of fresh water, without which you cannot survive. This watershed, even though it's incredibly important, is far over here on the right-hand side of my map of the United States. That little tiny sliver over there near the side, that's that Delaware River. The watershed I'm showing you here is a much more important watershed. This is the mighty Mississippi. This is the watershed that drains 40% of the land area of the continental United States. 40% of the drops of water end up in this one river. It is such an important water system, draining 1.2 million square miles and touching 31 states, that we use it to draw all the maps, right? So we start here in Pittsburgh, where the Mon and the Allegheny come together, and the Ohio forms the northern borders of West Virginia and Kentucky, the southern borders of Ohio and Indiana and Illinois. We draw our maps based on our water resources. Everywhere you step, you are in a watershed, and you are touching your water resources. Of course, there's a whole bunch of other stuff in your watersheds, too. And this is a map you may have seen in 4th grade science, I know, because I took it from my kids' 4th grade science textbook, showing you the many, many resources that we have in this country. We are incredibly blessed with coal and oil and gas and timber and minerals and fish. All throughout the watersheds where we have these resources, we have water. Everything we choose to do about all of these resources, we do in our watersheds. You live in a watershed. You drive in a watershed. You make all of your decisions, and you designed your entire civilization in a watershed. Every choice you made about your energy resources is a choice that affects your watershed. And let's take a look at some of those choices you have made. You choose to extract coal. You've been doing that for a really long time. In coal extraction, we take off the top, the soil, the trees, and we dig out the coal. We cause some problems in terms of the water quality, dam some creeks, produce some byproducts that we have to get rid of. You extract natural gas through hydraulic fracturing, which requires you to take water from the watershed to the well site, do the hydraulic fracturing, produce wastewater, get that wastewater away from the site. You build all of your power plants on your rivers.
This makes sense because a power plant needs a lot of water and a river's got a lot of water. So we build our power plants partly there so we can deliver the coal. It's a little hard to tell, but in the foreground here, those things that look about this big, they're huge coal barges. They're floating down the river bringing the coal to this power plant. We use water to keep the coal from blowing away. We use water to deal with the many, many wastes that come out of the coal-fired power plant, both the spoils shown here, which are the ash, and also we discharge wastewater from these locations that are produced in the power plants. Of course, you guys are probably from Pennsylvania, so I don't have to tell you about some of the regrets we have about our energy choices in the past. We have many, many streams in Pennsylvania that look like this, or that look like this, where acid mine drainage from old choices in energy, not current choices, choices your grandparents and parents made, still impact our river. We're, of course, not the only state with these kind of problems. This is a coal ash spill in Tennessee from a coal-fired power plant that was holding this ash in an ash pond. Now, lest you forget, because it's been a whole minute since I talked about your water, those exact same places that you are putting your energy resources, extracting them, affecting your watershed, that's where your drinking water comes from. Your drinking water is also extracted from these same water resources. If you drank some here today, this is where your water came from. This is the Pittsburgh Water and Sewer Authority on the Allegheny River. Its intake takes water that has fallen as rain and filled the river into the Allegheny, out of the river, treats it, and delivers it to you. Millions and millions of gallons a day. If you have driven up by Route 28, you have seen the large holding ponds in the background here. That's part of your water treatment system. That's not a pretty lake. Okay? And of course, you're probably aware that there's a little bit of a shopping center up there called, not surprisingly, the Water Works Mall. It is on top of the old slow sand filters that were used when this plant was first put in place. That water, way down here in Pittsburgh, doesn't come just from that river. It comes from that entire watershed, all that land upstream where the rain falls and it trickles down, just as you learned in 4th grade, into the little creeks and the big creeks of the river. This is your watershed that delivers that water. It's made up of lots of little towns, the little red dots here, and a lot of forest land, right? All that green. Some agriculture as well. But this is your watershed. It, of course, has water in it. So here are all the streams and creeks that filter down and end up in that main river. It probably won't surprise you to learn that it has coal in it, right? Underneath that watershed and those surface water resources is coal. It won't surprise you to learn that it has oil and gas, and we have been extracting oil and gas for a really long time. These are conventional oil and gas wells in the Allegheny River Basin in the state of Pennsylvania. Over the last 10 years, we've had a very significant advancement in oil and gas development in this region. That is hydraulic fracturing and long laterals for development of shale gas. So these brighter green dots, those are the unconventional wells drilled in this basin. Again, probably not going to surprise you that oil and gas development produces wastewater. That wastewater can be taken out of state and disposed of in deep well injections, or it can be taken to any one of these little starred locations where it is partially treated and discharged back to the waterways, which eventually end up in the river. And then, again, you probably won't be surprised. We have a lot of water, we have a lot of coal. What do? We build coal-fired power plants. It's a really great idea because the coal and the water are right here. So we have 9 coal-fired power plants in the Allegheny Basin, the largest of which are shown here in blue. The blue delineates that they have a particular control technology called wet flue gas desulfurization. I'll talk a little more about them in a bit. And then, again, I don't want you to forget, 59 drinking water plants. Okay? So we got all of those resources, and on top of all of that, you are extracting your water from this same watershed. About 1.5 million people are dependent on surface water in the Allegheny River Basin for their drinking water source. Now, that is a really busy map, a really busy map. I don't want you to panic. Everybody's map looks like this. This is not just us. This is what the world looks like. These resources are all on top of one another. I also don't want you to panic because the discharge points where we are putting pollution into the river are all treated. And more importantly, the drinking water plant kind of assumes they aren't. Drinking water plants were built in advance of most wastewater control technologies, but not in advance of wastewater. So the pollution was coming into the river, and we built the drinking water plants assuming that it would need to remove all of those. So I don't want you to worry about most of the things that are coming out of these sources entering your drinking water. We're not worried about most of them. I'm going to tell you which one to worry about. Okay, what I really want to talk to you about today is an unintended consequence. Now, anyone in the room who does systems research knows that it is all about unintended consequences. It is even our really good ideas, like I'll tell you about later, removing sulfur dioxide from airborne emissions at a power plant. That's a good idea. Removing mercury from airborne emissions at power plants, another good idea. Many of these good ideas have unintended consequences that are bad. Okay? The unintended consequence I'm going to talk to you about has to do with bromide. Now, you may never have heard of bromide. Why would anyone have heard of bromide? You might know it's on the periodic table. You might, if you have a pet who had seizures, have given them bromide because it's a medical treatment for pets. Or you might, if you're really lucky and you have a hot tub, you might have used bromide as a disinfectant. Other than that, you have probably never heard of this chemical. But this chemical is released into the environment from some natural sources like the ocean and from rainwater, and some not so natural sources like coal-fired power plants, oil and gas discharges, acid mine drainage, and even application of road salts. All of this bromide from all of these sources enters the environment, and it does nothing. Okay, I want you to leave with that very clear message. There is no problem with putting bromide into the rivers. No fish were harmed, no fauna were harmed. This does not bother anything. You can see why no one was worried, right? Because nothing happens in the river. Unfortunately, when that bromide which is in the river gets to your drinking water treatment plant, a very bad thing does happen. In your drinking water treatment plant, we treat your water. I know you're happy to hear that. We disinfect it. That's the last thing we do to it. We apply chlorine. That's really good because cholera and dysentery and typhoid are really awful. Right? It's incredibly important that at your drinking water plant, we add a disinfectant. We usually use chlorine. I'm sorry to say that when we do that, we form some things that are called disinfection byproducts. They're these things that form when you disinfect the water. You're not allowed to not disinfect the water, and you're not allowed to leave here telling anyone I told you to not disinfect your water. Right? We're absolutely going to disinfect your water. But it does form these disinfection byproducts, and they are carcinogenic. The carcinogenic disinfection byproducts mostly contain chlorine. But if you have unwisely put bromide in your source water, they will also contain bromine, and brominated disinfection byproducts are more carcinogenic than chlorinated ones. So what should we do? Well, I got an idea. We should stop putting bromide into our rivers. We should decrease the amount of bromide we're putting into rivers. What do you think we're actually going to do? That's right, we are going to increase it. So we have to control those points, but rather than decrease the amount of bromide going into the water from power plants, we're going to increase it because bromide addition is an excellent way to control mercury. I should take a poll. How many people think we should control mercury? Yeah. Right. Mercury emissions from power plant, bad. Don't leave here thinking I told you not to do that. Right? Mercury emissions are really bad. We do want to control them. The best way to control them is to add bromide. Unfortunately, the unintended consequence is that bromide is going to be in your drinking water source. And it's going to end up forming those drinking water disinfection byproducts. We looked at that. I'm going to show you specifically for the Allegheny, but I want to let you know that these plants are everywhere. Coal-fired power plants are all over the country, of course. We produce electricity in all of these plants all over the country. Where do we put them? We put them on the rivers, right? Because we needed a lot of water, and so we put them exactly where we put your drinking water plants. If we look just at the Allegheny Basin, there are those drinking water plants again, right? And there are those power plants. Now, I've shaded a few of the drinking water plants because if you are upstream, you should stop worrying right now. Water flows downstream. If you're up in the high basin, above those wastewater plants and above the coal-fired power plants, you got nothing to worry about. But if you're one of those darkened plants down there, which if you drank water here today, you are, those plants are downstream of these discharges of bromide, and they are going to see challenges associated with bromide. Let me show you the challenges we looked at. We looked at the bromide concentration entering the Pittsburgh Water and Sewer Authority intake under current conditions of discharge for, in this case, August. Now, August is the worst case. It looks better in March because it rains a lot. But in August, when it's dry, we see that there's a little bit of bromide, about 22 micrograms per liter coming from background, and there's about 50 or 60 coming from oil and gas wastewater, and about 40 from the power plants, for a total that's somewhere around 120, 130 micrograms per liter. Any chemists in the room are saying to themselves, micrograms per liter, what is she worried about? Right? These are really, really low concentrations. Typical concentration at a drinking water intake in the US is 30 micrograms per liter. PWSA and other drinking water utilities have said problems occur above 50. So this is not much, but it's a problem. If, of course, we add bromide for mercury control, I'm not going to surprise anybody by saying that if we add bromide, there'll be more bromide, right? And so we expect to see significant increases from the bromide. But, and here's really the important message I want you to leave with today. We chose to let power plants add bromide for mercury control. We chose to let oil and gas produced water be partially treated and discharged into our drinking water source. And we don't have to make those choices. We could, for example, decide that the power plant bromide issue is so important, mercury is so problematic, and bromide is such a better technology that we're willing to deal with the bromide, but we want to get rid of the oil and gas wastewater. Or, of course, we always have the option of saying, you know, 22 sounds pretty good to me. I don't want either of these sources coming into my river. So I want you to leave with the understanding that these are the choices being made, and they are being made in your name. This is the Pennsylvania Constitution, Article 1, Section 27. You, the people of the state of Pennsylvania, have the right to clean air, pure water, and the preservation of the natural, scenic, historic, and aesthetic values of the environment. The Commonwealth, those people who work in Harrisburg, they hold this water in trust. It is yours. It is your water resource. And as trustees of this resource, the Commonwealth is responsible to you for the decisions it makes about what it allows into your water. If you don't like these choices, you probably didn't know they were being made, but you now know they're being made. If you don't like them, do something about it. I will say in their defense that there is a law about discharges from coal-fired power plants. It neglects to account for bromide, but it exists. Okay? It was originally put out in the 1980s. In 2015, it was revised. Timeline for compliance is sometime over the next 20 years. Bromide is not directly included. You might think that's because we didn't stand up and yell that they should include bromide. I know none of you who know me think that that's possible. I stood up, really, we ought to worry about bromide. And bromide did make it into the final rule. Here's how it made it in. Depending on site-specific conditions, meaning if you live downstream, depending on site-specific conditions, it may be appropriate for permitting authorities, EPA, DEP, to decide that a water quality-based effluent limitation on bromide is necessary. That when I permit that power plant, that particular power plant, I can say no bromide. The overall regulation doesn't say no bromide everywhere. It says maybe we ought to look some places. So I'm here to tell you and hopefully leave you with the idea that you ought to look some places. That you ought to go find out if your drinking water utility is downstream of a coal-fired power plant, if I didn't tell you today. But go look at your utility. Is there a power plant upstream? Is the power plant discharging bromide now? Does it intend to discharge bromide if it complies with MATS by bromide addition? And then pick up the phone and tell your regulator that you want a site-specific regulation written for your drinking water utility to be protected from that coal-fired power plant. Within the Allegheny Basin, as within much of Pennsylvania, coal-fired power plant permits are almost all currently in an administrative extension process, which means they are up for renewal soon. Okay? Pick up the phone, write a letter, tell someone you don't want these decisions made, if you don't want these decisions made. You, we the people, these are our resources. This is our water. And we will have to live with whatever are our regrets. I thank you for your attention.